Hi guys, and welcome to the fifth part of TinyOS tutorial. In this part I'm going to talk about how to communicate using the wireless chip and wireless sensor boards to other sensor boards, and in this case I'm going to communicate between two TinyOS boards. So if you remember from the last tutorial that was about the user buttons, this time I want to do something. If user presses the button on the one of the TinyOS, the board will detect it and then generate a wireless packet and sends it to the other board, and one LED of the other board will be light up. So we are just going to continue where we left in the in the last tutorial. I hope that you have done your homework and you have made this user button test application, and if you have not, then you can just go back and see the tutorial number 4. Yeah, okay. We're just going to continue where we left. So I'm going to import this the user button test application. Because I don't want to touch that, so I'm going to generate a new project and work on that. So for this, as you have seen, I went to the Eclipse, I went to the file menu to import, and I want my import source be of TinyOS type. I'm going to press next. I'm going to name this project, for example, mote to mote, or node to node. It's just the name of project. And I'm going to go to the folder of our last application. It was in home folder. It was in home folder in workspace, and yes. Okay, I'm going to import this, and our platform is going to be TinyOS. I'm going to click finish. Now you have seen that the Eclipse created a new project and imported the existing files from the user button test application. So we are modifying this code right now. So let me open this module file. Okay, so I'm going to name this one mote to mote C. This is the naming convention that we have. And you may notice this warning. We're gonna fix it later, and we are not going to use the timer this time, so it's okay to remove it. Going to remove any code that is related to the timer. Also, I'm going to remove the event for the timer. Okay. And then I have to rename the file itself, so I'm going to name it mote to mote C. Okay, now you see that that warning is gone, because it was complaining that we have a module that doesn't have the same name in the file. So let's continue with our edit. Going to rename the configuration file also. Going to name it mote to mote app C. And I'm going to here we have to refer to the module file, and you remember we named it mote to mote C. Okay, this is related to timer, this line. We don't need it this time. Going to remove the wiring also. Now I'm going to rename the file, and it's gonna be mote to mote app C. Okay. We also have to edit the make file, and this is the error from EAT2. Come on. Okay, I'm going to change this to mote to mote app C. Okay, now everything should be ready. Closing this. So the first thing, the first new thing that we have to do is to make a header file, and in the header file we will make our radio packet, as I'm going to show you. So I'm going to source folder. I'm adding a new header file, and I'm going to name it mote to mote. So it's been created by the name mote to mote.h. So this is our header file, and what I'm going to do here is simply adding some definitions for the radio packet that we are going to use. So I'm going to say this is a NESC syntax, so just follow me and you will get the idea. So I'm going to say type def what? Oh yeah, type def syntax error. Okay, it should be of type NX struct. This is a structure that is being used by TinyOS. I'm going to name it mote to mote packet, or rather I would like to name it message. So this is going to be the message or packet that is going to be transferred to the other mode. And if you are familiar with NSC and C in general, you know that you have to give them this type of type name. So mote to mote message line T. Okay, and it's extract. Okay, so I wrote type def nx underscore extract mote to mote message. And now going to, there are quite a lot of data types that is specific to NSC language, and if you type nx and press Ctrl space, you're gonna see the defined data types. And for this task I'm going to just use a unsigned 16 int. And name this part of packet node ID. So it means that in my wireless packet or my radio packet, I want a chunk of data that represents the ID of the node that is sending the message. And I will show you how to make this in the module file later. And I will need another chunk of data, and it's going to be type unsigned int 8 underscore t, and I want to name this data. Okay, this is gonna be our packet. So the wireless module and the TLSP will send this packet, and this packet will contain some sort of headers that is going to be translated by the TinyOS itself, and it will also have a footer that is going to be a CRC check, and this is something that we shouldn't be worried about at the moment, but later in next tutorials I will show you how to deal with that, because it's going to be important. But just for now, think of a radio packet that contains the ID or number of the transferring sensor board, and it also carries a data, so we can store in this part of the packet a number between, because it is unsigned int of 8, and it's 8 bits, so we can transfer something like between 0 to 255. So you will see later how it works. Okay. Then also I'm going to introduce another constant, and for that I'm going to use enum. So if you're familiar with C, you know that with enums you can define a constant. I want to name this AM radio, and want to give it number 6. So if you're wondering what is AM here, AM in TinyOS is standing for active message. So it's how to say, it's a layer of communication, and 6 is a specific type that I will explain later. And I think we're done. So we don't need to add anything else here. So let's go back to the module file. So if you remember, I was suggesting that you keep the interfaces in different paragraph of code, so you can keep track of them easier. So I'm going to introduce the interfaces that are necessary for radio communication. I'm going to call this radio. And there are quite a lot of interfaces that you have to use for wireless communication, and you have to follow this to know what to do. Okay, the first one is the packet interface. So if I just press Control space, it will show it to me. So this is an interface that will allow us to work with packets and extract data from them. Another important interface is AM packet. So this is a special type of packet that is being used by the active message interface. And there's another interface. It's named AM send. So this interface allows us to send active message types or packets. And another one is interface split control. So a split control is a general interface that allows you to do some basic data extraction on data. So, but I'm going to call this as AM control, because we want to use it for controlling the active message. AM control. And then I think the last one is receive interface. So receive will help us to receive something, if either it is in radio or it is in serial port. But this time we are going to use it as for serial data. I mean radio packets. So we have an error here. Actually no error, because these interfaces provide you with some functions, or better to say events. So we have to implement these events. So I'm going to put my mouse here and add the event for this interface. So AM send has an event named send done, and this will be triggered or raised when the sending is completed. So you can do something here to indicate that the sending was successful or not. Then AM control or split control has a event handler. I mean events that its name is start done. So when the split control is started, then you can check here that it is if it's really started or not, because it will pass a constant of type error t. So it will be a success or will be a problem. So I will show you how to deal with that again. Also, it also provides another function or event named stop done. So when you are going to stop the radio, here you can check if it is really stopped or not. And the last interface function, this is the receive event from the receive interface. So I added all this. And notice we have an error here, because this event, unlike the others, expects a return value. So I'm going to, for making this happy so it doesn't complain anymore, I'm going to just return the message that it is received. So here is the data type that is it's supposed to be returned from. So I'm going to just say return message. That was already passed as an argument in the method signature. Okay, now we are set. everything is okay now. Now we have to implement the logic of radio communication here. Okay, and the first thing is we need a variable to store the state of radio chip, and it is just a simple boolean, and you can say bool. Well, I personally like to start my variables with an underscore. It's a habit that I got from C# coding. Radio busy, and I want to set it at the beginning to false. So we have an variable that will store the current status of the radio. So we can check if radio is busy. We wait for until the radio is becoming free again, and this is something useful. And I want to have a variable of type message t. The message t is the top layer of a message or packet. So I'm going to name it underscore packet. Okay, these two variables, we are going to use them later, and notice that we have just put them after the implementation, so these are going to be global variables, and we can refer to them in inside the methods or functions. So let's start with boot event. So you remember from the user button test, we were enabling the notify event from the for the user button, and now we need another one. We want to AM control or the split control to be started. Okay, so as soon as our sensor board is booted, we're gonna enable the notify for the user button, and also we are going to enable the radio chip using this command, call AM control, or if you didn't use the ASK keyword, it would be split control, and start it. And later in the configuration file, I'm going to tell you why we call this AM control, because we are going to wire it directly to the radio. Okay, so AM control is the start, and remember here we had an event that was here, AM control start down. So this happens when the start is completed. So here we have a chance to detect any problem that might be occurring. So for that I'm going to say sorry, you know, we have a error here. We have an argument of type error t, an error. So we can check the value of this error, and if this is success, then it means the radio chip is on, and if this is not success, the radio chip is off, and we can try to enable it again. So I'm gonna say just simple if error equals success, and this success with all capital letters is a constant in TinyOS, and its value is 0. So you could say just 0 or just use success, but if you use success, it's gonna be more readable. So if error is success, it means that we have no error. It's kinda seems to be funny, but this is how the things work. If error is success, let's see, we want to indicate that it was really successful, so we can say call for example, let's turn the for example, let 0 on. I'm sorry. So if the radio chip is started without problems, we're gonna turn on the let 0, and to say let 0 on. Oh no, sorry. Let 0 on. And now we have a chance, and we can say else if by any chance that radio chip was not started. Maybe it was busy before, or maybe it was occupied by the UART 0, because if you know on TLSP, for example, UART 0 and radio chip are using the same bus. So if the UART is active, then you cannot enable radio chip. So if it was a failure, so we checked if it was success. Now we can, and if it was not successful, we're gonna call AM control start again. So this will loop. So if it wasn't successful, it will call AM control start again, and it again will run this event. And if it was okay, then it will exit this loop. So that's some sort of trap, so you have to be careful about that. Okay. Now we have to go to let's go back to our notify event and create a packet to be sent. So when the notify is enabled, you remember we had the two constants, button pressed and button released. So if the button is pressed, we want to create a radio packet and tell the other sensor board that the button has been pressed. So how to do that? I'm going to show you right now. So let's say creating the packet. So remember from the header file that we just made, or packet or data packet was named mote to mote message. So we are going to make a new instance of this data type. I'm going to say mote to mote message, and you have to remember this is the what you call a pointer. Yeah, message equals, now we can call the using the packet packet interface, call its get payload method. No, sorry, get payload, and in the first argument we want to save it to the packet that we just created here. So this is our packet holder. So this is the top layer. So any kind of packet type we make, anything that we can define as an NX struct, is going to be compatible with message T, because this is the just look at it as a class. So when you have a parent class, then you can have child classes, and because the child classes are inheriting from the parent class, then they can be casted to each other. So just think of this as a class, but it's actually a data type. So I'm going to get a payload, or what is being received to the packet variable that we introduced here. And the second argument is the length. So this is a way to check if the packet is what we are expecting. So because for example, you can have like 100 packets coming into your sensor board at once, but you are only interested in one kind of packet. So we can check for its length and its signature. And how to do that is to use the size of function. So we want something that to be size of or defined packet, and it's going to be mote to mote message underscore T. And you notice that there's a problem here, because it doesn't recognize the packet that the type of the packet, because we didn't include the header file. So I'm going to include the header file that we just made. I'm going to say just include mote to mote.h. Now you see that the problem is gone. And if you're wondering why this include uses the greater and smaller signs, and this one is using the double quotes, The difference is when you use double quotes, it's not the compiler is not going to search in the defined folders, so it directly looks inside the actual source folder, and this will speed things a little bit up. So I could just use this, but the compiler then has to go and check every folder, every possible folder, to find this specific file. So I'm going to just call it like this. Okay, what we done here, we created a message or a packet, and now we are going to set its data types. So this is how you do it. You remember that we defined in the packet definition a node ID and a data. So I'm going to set the node ID with a constant that is _node _ID. So this is not some magical things. When the compiler is compiling the program and uploading it to your chip, you can give a command during the uploading the application to your sensor board, and you can set the internal ID of the sensor board, and I will show you later how. So just know that you can use this constant _node _ID to represent the name of the ID of the mote that you are working with. For example, if you have like 15 modes, each of them will have a unique ID, as long as you you give it during the upload to the sensor board. Now I'm going to add the, you remember we had another one, data, and this data is going to be the value that is passed in the notify event. So I'm going to just simply say this should be val. And you can see here there's an error because it doesn't know if val is because we defined the data as an unsigned int of size 8. So it's gonna work like this, but to remove the confusion, we can just cast this as uint 8 _ t. So this is the way that you cast data types to each other. So this value, if it's anything, then it's going to be converted to int of unsigned int of 8. Now we have created the packet. Just look at this again. Now we don't need this anymore. So let's see what we have done so far. We created a packet. We assigned the node ID of the sensor board that is going to send this packet. So on the other side, we can check this ID and see if this packet is coming from the sensor board that we are interested in. For example, you could have like 20 sensor boards, and all of them are sending packet at once, and you want to just react to a packet that is going to be coming from a specific sensor board. Now we are just going to send this packet, and how to send the packet is quite easy. Sending the packet. So remember we had this AMSend interface. Now we can use this to send this packet, and I can say call AMSend, then it has a send method that accepts 3 arguments. And the first one is the address that you want to send to. So if you know already the address of the mote that you want to send this packet to it, you may add it here. Or if you don't know, in this case, because I haven't done the program for the other mote, I'm just going to use the broadcast address. and broadcast address is am underscore, is also a constant in TinyOS. Broadcast, so you see broadcast address, no, it's, I believe it was yeah, it's hard to remember all the constants. So I'm going to broadcast this this packet to any mode that is within the range of the radio. And what we are going to send now, this is the packet that we had, and what its length is gonna be is again to be size of or packet's data type. So what this will does, this will send the packet through the radio, but you remember we had this radio busy false. That's how this is gonna work, because we have the send and we had that event that was send done. So this is where you have to use this variable, because you want to make sure that during that you are sending this packet, you have to flag your radio chip as busy, so it cannot mess up the other incoming or outgoing messages, and actually store them in the buffer and process them later. So for this, I'm going to say if this action was successful, we're gonna mark our radio busy to be true. So this happens in the time of sending this packet, the radio will be busy, so we want to set it as busy. Now where we have to check if the radio was not busy before. So I think the best place is here. Right before we create the packet, we want to check if the radio busy is false. It means the radio is not busy. So I'm going to put the whole things that we have done so far in this if statement. Okay, now everything seems to be fine. And I think we have to make something inside the send done also, because this event will be this is where we can set our radio busy to false again, so we can say that the radio is not busy anymore. So I'm going to say if the if this message to be sent or has been already sent was the same as the packet that we made, we can now make sure we can be sure that this packet was sent. So I'm going to mark the radio busy to false again. So if the next time user wants to press the key and comes here, the TinyOS will know that the busy radio is not busy anymore. Okay, let's review what we have done so far. We had the notify event of the user button. When this notify event triggers, it means when the user presses the button on the sensor board, we're gonna check if the radio is busy or not. If the radio is not busy, we're going to make a new packet and assign the sensor board's ID and the data that we want to transfer. For example, if this value was button underscore pressed, this value would be 0. If it was a button underscore released, it will be 1. And then here we have sent the packet, and when this packet is being sent, we can check it through this event that is send done, and mark the radio busy to false again, so it will be ready for the next event if the notify event is going to be triggered. Now let's think something about the receiving part. So we send a packet. Now what we have to do for receiving a packet. Okay, we're going to do this inside the receive button, because we are going to upload the same program, the same application that we are making on two different sensor boards, but with different node IDs. Okay, this is where we can receive the packets. Now we can say, so this receive function or event will be executed whenever the radio chip receives any packet. So this means it can receive anything that is compatible with TinyOS packet type. So if you are working in a university or in a campus or something, if your friends also working on the TinyOS, and if they are using the same radio channel and the same IDs and broadcast IDs, then you're gonna receive from everyone. And that this is not something you like to have. So you have to check the packet that is being received is the packet that that is belongs to you. So how to check that? Again, we can use the size of function. You see when the this receive event triggers, 3 arguments will be passed, and one of them is the length, and this is a good measure to check if it's the same packet that you are looking for. So we're gonna say if the length argument, or LEN in this case, is size of or mote to mote message data type. Now we can be partly sure that this packet was meant to be for us. Now we have to read the packet, the content of the packet. How to do that is also easy. I'm going to say mote to mote message underline T, again using the pointers, don't forget. I'm going to name it incoming packet. If this is equal or is the same type of the message T, so I'm going to use a cast function, a cast action here also. The payload is the packet that that was received. So this payload can be anything. So you have to make sure that this is compatible with the data type that you have. Okay, I'm going to paste it here, payload. So we have casted the payload to data type of our interest. Now in the receive event, we're gonna check for the because now that we have casted this packet to mote message underscore T type, now we can say access its content. I can just copy it here. You see that because we casted it, now we can access the node ID and the data that is coming from this packet. So I'm going to check if the node ID equals, for example, 2. I can continue because I know that this packet is coming from a sensor board that I previously gave the ID of 2 to it. But this time I'm going to leave it, no, sorry. Going to not to do this, and I will do it later just to prove you some points. So I'm just now interested in the data that is inside the packet. Now I'm going to say incoming packet data, and I want to store it in a local variable, so I will say uint8, and I want to call this let. No, let's call it data. So anything that this is inside of this chunk of the packet is going to be stored in this variable. I cannot make it 16. I can make it because it's a bigger value, but you remember that the data in the header file was of type unsigned int 8. Okay, now it's time to take action. So now I can say if data is 0, remember from the user button, 0 means that the button is released. So if the data is 0, I'm going to, no, let's first make it 1. If the data is 1, it means that the user on the other mode has been pressed the button. I'm going to, now I want to show that, and I just going to say to just light up one LED. In this case, let's say LED 2, because this is the most bright LED on the TLSP. LED 2 on. So if the user on the other mode has pressed the button, I'm going to turn the LED 2 of the receiving mode on. And if the data was 0, that means it was released, I want to turn that LED off. Call LED 2 off. LED 2 off. Okay. Now it seems that everything is almost ready, and we have a simple error here. LED 2 off. Let's call LED 2. There seems to be a slight mistake here. LED 2 off. Okay, it should be fine now. Okay, you have noticed that we are not doing anything inside the stop done event of the AM control, because we are not calling the stop anywhere in this code. But if you're in your application, if you want to stop the radio, you can check if it's really stopped here. Okay, I think we are done with the module file. I'm going to save it for now, and I want to go to the configuration file and introduce the components and wire them to the interfaces. And later, if we had any problem during the compilation, we're going to come back to the source files and see what was the problems. Okay, it's now time to fix our configuration file. I'm going to the configuration file here, and as I told you before, it's also a good practice to keep your components in categories. So for example, these are the general components, and these are the components that are related to the user button. And now I'm going to make a new category and call it radio communication. Okay, now we have to use I believe three components that are providing us with these interfaces that we use in the module file. And components, the main one is active message C, and another component we need is components AM sender C, and this component requires some sort of initialization. And you remember that in the header file we decided to give this type of communication using number 6, and this number 6 is the active message type of our packets. So just follow me and you will get the idea later, I hope. Components. Another component we need is AM receiver, and again we are going to use the AM underscore radio, the concept we made. And yeah, these two components should be initialized, so that's why I use the new keyword. Oh, what is happening? Okay, I don't know what was that, but anyway. Now it's time to do the wiring, and it's the interesting part. So you remember that we are referring to our module file as app. So I'm going to do the wiring. I'm going to wire the packet interface to AM sender. I'm going to wire the AM packet to also AM sender. AM send interface should be wired to again AM sender C, because this is the main component that provides these methods inside these interfaces. So I think by now you should know the idea of the component and the interface in TinyOS, and if not, then you have to study more, I guess. Okay, AM send. Then we have we had AM control, but it was actually a split control, but we refer to it as AM control because we use this as keyword. So let's say app.am control. This one should be wired to AM. No, it should be wired to active message C. And finally we had I believe receive, and we also have to wire it to receiver, AM receiver. Okay, now I don't see any problems here, so let's check again. So AM radio, let's make our code to look better. Mote to mote. Okay, I think it's almost ready. I'm going to the command line and try to compile this, and if there was any error, we have to come back here and fix it. So I'm going to workspace, to mote folder, list of files. Let's first make this window a little bit bigger so we can see the errors. Okay, I'm praying that this works. Make TLSP. Yeah, it worked. We had no problems. And now I have attached two TLSPs to the USB ports of my computer, and if you already know, I'm using the the Oracle's VirtualBox, so I have to add the TLSPs to the VirtualBox so they can be detected inside the VirtualBox environment. So I added both of them. Now I'm going to use the command mote list. Actually, I can only see one of them now. Okay, the second one was just configured. Okay, now we have two TLSPs, and one of them is sitting at USB 0, and the second one is sitting as in USB 1. Okay, now it's time to compile. First step is to change the mode to write. So I'm going to say sudo change mode to 666 for the first one, tty USB 0, entering my password. I'm going to give the write access to the second one also, tty USB 1. Now we have write access to both TLSP modes. Now I'm going to we had the previous build, so I'm going to clean the I have to use the make clean. So now it's time to upload the application to real sensor boards, and you remember that I was talking about the constant TOS underscore node underscore ID. This is where I can set the ID of the modes during the upload. So I'm going to say make TLSP install and use dot. Now I can put the ID after this. So this is going to upload this program on one of the TLSPs. That is going to be on USB 0, and you have to also use the BSL command and comma, then the address of the USB port /dev tty USB 0. So let's review it. We are going to make this application, install it on the TLSP board, and give it the TOS node ID of 1 and the one on the USB 0. So it's erasing the previous and it's now programming it. Okay, the first one is done. I'm going to repeat the same process for the second one, second TLSP that was sitting on the USB 1. So you'll notice that I changed the 0 to 1, and this one I want its node ID to be 2. Okay. Seems to be working fine. Okay, now let me try it myself first. Okay, this is working. Okay guys, just wait. I'm going to my table and show you what is the result of the program that we made. Okay guys, I'm here on the table, and as you can see I have two TLSP sensor boards. And don't mind this cable, this is just to power it up because I don't have extra batteries for this one, and this one is battery powered. So this is the result of our program. So you remember, when the radio chip is enabled, we light up the LED 0 of the TLSPs to indicate that the radio is on. Now if I'm going to press one of the user buttons on this, for example, the other one should make the LED 2 or the blue LED on. So I'm going to try it. Yeah, it's kind of hard to press this. Now I just pressed the reset. Okay, I'm pressing this, and that one is lighting the LED. And same thing for, because we use the same program for both, it should do the same thing. Okay, this is the result of our work so far. I'm going back to my PC and talk a little bit more. Yeah, so see you. Okay guys, there you have it. This was how to use the wireless communication between two sensor boards. The basic idea is the same for almost every sensor board. If it's Mika Z or Z1 or anything, you have to use the same interfaces and you have to do the same kind of wiring. And yeah, there you have it. And if you had any question, oh no, first I have to talk about the node ID. So you remember we could access this this part of our wireless packet and check from which node it is coming. So but if you want to use this, then you have to first change it to 1, for example, in this one, then upload it to the TLSP, then come back and change it to the other one, and then save it and upload it to the TLSP again. This way you can have a control over from which sensor board you are receiving the packet. Yeah, I think that's all for this tutorial, and in the next one I'm going to talk about how to read, or I mean receive the packets from wireless inside using the USB or the UART on your PC. For example, you want to read the sensor data, for example the temperature, and you want to show it on the screen of your PC. I'm going to show you that, and meanwhile I suggest you to follow this article and tutorial and try to do it yourself, and also visit my website And if you had any problems, you can go to the forum, register here, and there's a subforum here called TinyOS, and I'm going to be happy to answer your questions, of course, if I know the answer. And if I don't know the answer, then I can't help you. But almost I know almost everything about TinyOS, so there's a big chance that you're gonna get an answer. Yeah, thanks for your attention, and see you next time. Bye.